So if you are watching at home, I just started recording. And so pause right here so you can get caught up, so you can get all those numbers. We're going to keep rolling on here to find the lower boundary for the outliers. Hopefully you remember that Q1 minus, right? Upper boundary will be Q3 plus. Right? I want to be a little bit less than Q1 and a little bit more than Q3 to kind of stretch my boundary out. Like maybe I want to be at like the 10th person and the 90th person or something like that. It depends on how big and how spread out numbers really are. Okay, and what we're going to subtract and what we're going to add, of course, is the same thing. All right, that 1.5 times the IQR. And this is backed up by the statistics itself. This is not something we're making up. This is years, decades, centuries even, of kind of working through statistics and kind of getting some formulas that work. Statistics is fairly new compared to a lot of different kinds of math. I mean, algebra, like super old, trigonometry, super old, geometry, stuff like that. Stats is kind of new, which is why it's more applicable, I think, to a lot of the careers that you guys are probably, career paths you might take moving forward, which is why you don't have to take a class like calculus necessarily. A stats class, super, super helpful just to have a good background so you can go for it. If you want to keep going, I mean, there's so much statistics. I took a couple graduate level classes in stats, blew my freaking mind. I had no idea the stuff you could do. And we're actually going to get into some of that stuff, hopefully like February. You'll see some college level stuff, which is pretty cool. All right, sweet. Now I need a calculator because I got to do that 1.5 times. So let me figure out what numbers I got to plug in. So Q1 61.5 minus 1.5 times 10. That's actually not that bad. Since we're just multiplying by 10, I just have to move that decimal over a little bit. But I'll let the calculator do it so I don't make any mistakes. 61.5 times, sideways so I can get my parentheses there. 1.5 times 10, which is just going to be 15. But I'll type it in just to be safe. Does all of the, oops, typed it in wrong. 61.5 minus 1.5 times 10. So 46.5. That's my lower boundary. Now, just so I can see it, let's see. Yeah. I like to kind of just keep an eye on where that boundary starts and ends, and it looks like we've got one, right? It looks like we've got 44 is less than that. Okay, I'm looking for numbers that fall left of that IQR times 1.5, right? That space that's below there. So do I have any lower outliers? Yeah, 44. Too small compared to everybody else. So my new minimum is the next one, right? My new actual minimum, just for these modified box plots, is the one that isn't an outlier, but still super low. Cool. Again, questions, just stop me if you've got anything that's bugging you. Okay, and the same thing up top here, 71.5 plus that 1.5 times the IQR. I let the math take care of itself here. That's the thing about stats that I really like. It's not so much like algebra where you have to like know certain steps and I got to add and subtract the same thing or multiply, divide. A lot of statistics is formulas that we can look up and just plug our numbers in and let it take care of it for us, or like graphs that we can use that are already there. I just look at them and I find how certain points, I should probably actually write in the IQR here. Like things that we can just look up. A little bit less, I have to memorize like how to approach different problems. Really, it's the same problem, just different numbers. So that's pretty cool. At least that's what I like about it. Cool. So our upper boundary here looks like 86.5. And just because I can't see it quite as well, I'm just going to erase these last two. Oh, okay, nice. 75 and 80. No, I'm good. 86.5 is bigger than my biggest one. Do I have any upper outliers? I would just say no. No, I'm good to go. And because I don't have a new maximum value, I like to just cross out, if I'm doing it this way, cross out the word new and really kind of stick with the fact that 80 is that number that I liked the first time, and I'm just going to hold on to that. I'm just going to take a picture so I can go on to the next page. We can draw this stuff out, and I'll do one more. Boom. Okay, cool. There we go. Questions on any of that? Back you guys up so you can see me a little bit more. Is this stuff starting to sink in? Those of you that I can actually see you, thank you for turning the camera on. Is this all good? Okay, cool. Let's do it. Let's graph this thing. Now, our numbers are bigger, right? We don't really have super tiny numbers at this point. So our box plot doesn't have to start at 0, doesn't have to start at 5. You know, we can make, since I'm just gonna write these down so it's easier for us to see, right? My new minimum is 50. So maybe I'll put, maybe on the side here, I'll put any like little outliers. Let's put out over here. I got 44. That's a little bit too small. So remember to put the like the star or the X or whatever I'm gonna do on that side. Okay, cool. So I've got an outlier 44 minimum at 50. Q1 was 61.5. So sloppy, I know, but you got the numbers. 66.5 for the median. The further up I go when I write on this thing, the more it gets confused by my hand. It thinks I've got like 2 different fingers kind of trying to draw on the same side. Maximum was 80, and we like that one because our upper boundary was 86.5, so we were right there. So we just want to create a scale that works, like for that. And so why not like start at your lowest one? Now, if you wanted to start at like 40 and give yourself some space, that's fine, you could do that. But if you want to start right at that lowest value, you can do that. We'll just put an X right over there. That's okay. To give ourselves a little bit of space, let's see what happens. Now, so I'm just going to write 40 here just as an option. And we'll see how far we can go. Well, I think there's like 30 boxes here. So that won't be enough to get us to 80 because that's 40 boxes away. So I think if we go by 2s, we're probably pretty good. And so far, we've been skipping every other one and kind of writing it down. So like I'll write down 40, and then I'll leave off 42. I know it's there, but then 44, skip it, 46, 48, skip 50, 52, skip 54. I think it's pretty good. It gives me an easy way to find the numbers I'm looking for. You can probably write less. You can certainly write more. Skip 58, let's go 60, 62, skip it, 64, 66, 68, skip 70, 72, skip 74, 76, skip 78, and we'll get to 80. That's pretty good. We're using most of the space. I like giving a little bit of space on the left and the right. Gives me space for labeling my graphs or whatever I need to do. So we've seen that a lot, kind of leaving a box or 2 of space. Never a bad idea, as long as your graph kind of fits nicely. Cool. Kind of pick up a middle line on which to put your now 6 numbers, because we do have 1 outlier that we're going to put that X. So to me, I just kind of look for the middle, which is this line right here. And so 44, because that's an outlier, I'll put an X. Or a star or an asterisk or whatever you want to kind of separate it from everything else. I don't put a dot like there like I do for the other ones because I want to make sure I don't mistake that for my actual minimum in these modifier boxes. Cool, 50 is a perfect spot. I'll put a small point right there because eventually I'll draw that vertical line. 61.5, a little bit more than, more than 60, less than 62, but pretty close to 62. So a little dot right there, closer to the 62 line than the 60. 66.5, so 64. There's 66, so just a little bit past that. All right, 71.5, so there's 68, there's 70, there's 72, so pretty close to 72 right there. And then 80, I got a perfect spot for that. All right, so you get your 5 points and then just that 1 X if you want to use an X or whatever you guys are doing. You can write whatever you want, right? You got some flexibility there. So, a cup of coffee, number 2 today. All right. Minimum and maximum lines are just 1 box up and down. Straight edge if you've got one nearby, edge of a notebook, edge of a driver's license, actual ruler, whatever you want. Works for me. And then for Q1, median, and Q3, just make them bigger. Okay, 2 boxes, 3 boxes, 4 boxes, all the way up, all the way down. Let's do that. We haven't done that yet. Let's go all the way up, all the way down. 1, 2, 3, 4, 5. Is it even? 1, 2, 3, 4, 5. That's the key. If you pick a midline that actually isn't the middle, you got to make sure you go up and down the same number of boxes. Because we did a good job and we picked a middle, we can go all the way up and all the way down. Don't do it if you don't want to, but hey, why not? Mix it up. Keep the brain thinking. This kind of stuff can get kind of repetitive, so mixing it up for you is never bad. Sweet. Okay, across the top of your box, across the bottom. Okay, but no line in the middle. Okay, because that's only for our. And there's that box plot. Okay, big difference between your minimum and Q1. So that means there's probably a bunch of numbers in there. Right, a lot of numbers fall in that space because it's long. Not a lot of points, right? Necessarily stuck in different spaces. Right, so it kind of depends on what you're looking at. Right. Box plots can be trickier to read than other things in terms of how many points do you have. It's really more about how spread out your data is. Right? But it does give us a good sense of how to like analyze individual pieces. So don't actually draw this, but just so you can see it. Like if I put a point like right here versus, right here, student A versus student B, it kind of gives them a sense for where they fell compared to everybody else, right? Shorter than most, taller than most. And it's really easy to see that rather than having to say, okay, you're 76 inches tall. Where are you? Or you're 51 inches tall. Where are you? Right? So that kind of makes it nice. Sweet. There you go. There's our first one. I'm going to back out because we don't really need. Let me go any further back. Whatever. Ignore that little. Can I erase that? Let's see. Working pretty well. Hopefully, seeing me draw these out rather than the animations on the PowerPoints help a little bit, especially since we're drawing this way. Cool. All right, let's do another one real quick. Now that you have the hang of it, I want to work through it a little bit faster so that you can get yourselves out of here hopefully by 10 o'clock. That's what I'm shooting for. All right, same idea, same kind of setup with the points, which I know isn't great. But this is actually you guys again, which is way more interesting than just me picking data off the internet. We asked you how much battery life was left on whatever device you were looking at. Somebody had 4% left, and a bunch of people had 100 because they were either plugged in or they were on their desktops. But a lot of 99s, 98s. Again, probably people that had just charged it or were actually charging it while they were doing it. Cool, so let's do it. 5-number summary real quick. We got to find ourselves a minimum and a max. Those are pretty easy because it's the lowest one 4 and the highest one 100. Even though there's a bunch of those, it's still the maximum value. We just pick the one. And our median is, of course, down the middle. So I have a feeling it's probably going to be halfway between that last 80 right there and the first 85 right there. Right there, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pairs there. So that's 30 data points, which is really the number you're always shooting for. We want our, if you have 30 points of data, it usually gives you a good understanding of the larger group. So if you're looking at 1,000 people, if you randomly select 30 of those people, you'd be surprised how close that random sample, as long as it's truly random, and we'll start talking about sampling and bias and stuff like that, how close that actually is. It's pretty cool. All right, so 80 and 85 are left, so I gotta take the average, add them up, see what you get, divide by 2, or just find the middle, 82.5. Okay. Now, same thing, but just in the top row to find Q1, because we didn't use 80, I get to cross it out. find the middle, and you can see I'm using different colors and I'm drawing my slashes through them in different directions so I know how many I've done, right? Now what's nice is because we have 30 data points, when you chop those in half and you have your two rows, the top row only has 15. And if you've got an odd number, there's gonna be a middle, right? And that number is that one right there that I can't see all that well. Okay, 62. And although some of us don't love the fact that we've got these two rows, sometimes it's really nice to have just one big long row. Because they're even, I know that that right there is going to be my Q3. Now, I can prove it by crossing them out. And there we go. We get ourselves to that spot. So that saved me a little bit of trouble. Oh, 99, nice. Right. I got a feeling that 4 might be an outlier. If my middle is 82.5. Let's see, maybe even some more numbers down there at the bottom. All right, got to find the IQR if we're going to figure out these boundaries. So Q3 minus Q1. So 99 minus 62, and that's why I stuck with those different colors there for Q3 and Q1, because those are the ones I'm going to use. Calculator or in your head, whichever is comfortable for you. You get 37. And then Q1 minus that 1.5 times the IQR, and Q3 plus 1.5 times the IQR. Definitely going to need a calculator for this one because my numbers are kind of big, right? 37 for an IQR is pretty big. Q1 62 minus whatever 1.5 times 37 is, no idea. Let's do it. Turn it sideways, clear it out. 62 minus parentheses 1.5 times 37. Close parentheses. 6.5. Wow. Even though the data tends to lean towards the right here, they've got a lot more points like above 50 than we do. Because there's a big difference between Q1 and Q3, our boundary is actually really close to the minimum. It's because that spread is so big, right? And so when we're looking at possible outliers, all right, so there is the 4 and the 8, the space is going to happen in between, all right? So just right there, just the number 4, that's our new outlier. So our new minimum is the next one, right? Just going to be that 8. Again, stop me if you need anything. I got a pretty good feeling we're not going to have any upper ones if we're going to do 99 plus a pretty big number, whatever that 1.5 times 37 is. Which makes sense because all of our numbers are kind of lumped together towards the top. And that's what we're talking about. We're talking about outliers. We want stuff that's kind of far away from most of everything else. Yeah, 154.5. If you've got phone battery that's 154%, you let me know because I'm looking for a new phone. All right, no upper outliers. So no new maximum. 100 is going to cut it for us. All right, take a picture. So we can draw our box plot. Voila. And away we go. I'll write down our numbers at the top there. And if you need copies of anything, you just let me know. I'm happy to share stuff with you. So we did have a lower outlier again, so I'll just put like out down here. Okay, that's a 4. Our new minimum, my goodness, that's supposed to say minimum, is 8. Q1, what did we figure out? 62. Median, yikes, 82.5. Q3, 99. And our maximum of 100. Now, we've got to fit all of those numbers. I'm gonna probably have a pretty big scale from spot to spot because we have to fit all the way from 4 up to 100. And I think if we go by 5s, and I'll start it, you can start at 4, or you can start at an easier number to count by. And I like to do that. If I'm going by 2s, it doesn't really matter where I start, but if I'm gonna count by 5s or 10s, sometimes it's nice to pick an easier number to count by. If I go by 5s, do I make it? I think so, because we've got 30 boxes. So 5 times 30 would be 150. So that would work. Could you go by 4s? 4 times 30 is 120. Yeah, that could work. But now you're counting by 4s. 0, 4, 8, 12, 16, 20, 24, 28. Maybe you don't like that nearly as much. Could you go by 3s? Let's see, 3 times 30 is only 90, so we wouldn't quite make it. So going by 4s, I think, is a good choice. It's probably the best choice to maximize your space. Going by 5s might be easier to count out your boxes faster, especially if we're skipping a box. That means that every other box is just worth 10. So I could just go 0, skip a box 10, skip a box 20, skip a box 30, skip a box 40, and so on. And even though it doesn't use all of my space, I try to use at least half, if not more, okay? I would probably be more like over here if I went by 4s, but that was way easier to scale out, okay? And as long as your scale is consistent, you're good to go. Cool. Best estimating that you can do is really what it's all about. Find your middle line. You'll see tomorrow when we start comparing box plots, I will tell you where the middle is. It makes it a little bit easier. Hopefully you've picked up some notes. If you haven't, definitely drop by school today and pick stuff up. It just makes this so much easier to draw stuff out. All right, outlier at 4, so 0, 5, just a little bit less. I'll put an X, just the one. And you have, remember, you have an X for every single outlier. Now, if we had like 4 or 5 or 6 different outliers, okay. Now I've got 4 or 5 or 6 different X's. But if it's a repetition of the same number, like if I had 4, 4, 4, 8, 12, 19, 37, 62, whatever. Well, if I have 3 different 4s, same number 3 different times, I can't really draw 3 X's on top of one another, and you see that, and that's okay. We just draw the 1 X for that one spot. Cool, minimum at 8. So it's pretty close, actually. It's right there. So that outlier isn't super far away from the rest of the data, but it is there. All right, so wow, 62. Yikes, way over here. 62, almost halfway between 60 and 65. And that long whisker tells you how far away your minimum is from your Q1, which tells you that there's not a lot of points in between there because most of the data is far away from it. Okay? 82.5, exactly halfway between 80 and 85, because we actually did that, right? Remember, we took the average between 80 and 85 to find that median. Q3, 99. Now, 99 and 100 are probably closer together than I am able to graph that. So I use a little artistic freedom to draw those points probably a little further away than they actually are, so I can draw the whisker. Okay, don't worry about being perfect. Do the best you can. 1 box up and down for my min, 1 box up and down for my max. You can see how short that line is, which tells you how many points. The shorter the space between spots on a box plot, the more points there are. Okay, I'll just go up and down 2 this time. Why not? Mix it up. Up and down 2. Up and down 2. I don't care which one you do. You can pick any size you want as long as it's just bigger, right? Across the top for the box, across the bottom for the box. Tiny little whisker right there, but you can actually see it, which is the key. And then super long one on this side. Again, the longer the space, the fewer the points that you have. I mean, they're all like, here's 25% of the data, here's 25% of the data, here's 25% of the data, here's 25% of the data. That's the idea. Done, just 3 minutes over my hopeful mark of 10 o'clock. I will send you all on your way. Thank you so much for dropping by today. Put this work up on Canvas. If you didn't upload anything from yesterday, then do yesterday's work and today's work so I can see all 4 examples that we worked through. If you just uploaded your stuff from yesterday already, then I don't need to see all 4 on a separate submission, but you can if you want. Cool. Stick around if you have any questions. Otherwise, hasta mañana.
Bye, Rosie.
Peace.
Later, Rosie.
See you, Rosie.
Thanks,
Thanks,
Rosie.
Thank you, guys. Appreciate you.